Let's start with how we organize our Dataform repo. For each analytics team, we recommend having one GitHub repository. Inside that, every workspace will contain a definitions folder. This is where all your modeling logic lives. To keep things clean and modular, create one subfolder per report or analytics pipeline. For example, definitions sales funnel report, definitions order summary report. Each folder should contain all the models related to that flow. Inputs, transformations, and outputs grouped together. For naming, use lowercase with underscores and prefix your files with numbers to show execution order. So instead of dumping everything into one file, you'd write something like o1_user_behavior.sqlx, o2_order_details.sqlx, o3_user_segments.sqlx. This structure makes it easier to reason about logic, manage pull requests, and onboard new team members fast. Now let's talk about how you structure your logic inside each SQLX file. Instead of dumping everything into one long chain of CTEs, group related logic into focus blocks. Each file should represent a clean, logical step in your pipeline. For example, if you're doing all the fixes for order_items, keep that work inside one file. If you're building user segmentation, keep all that logic in its own file. Think of each SQLX file as a blueprint block. Inputs, transformations, and output, scoped to a single purpose. When your files are clean, the compiled graph stays readable, debugging gets easier, and adding new models doesn't feel like surgery. The goal is modular, reusable, and traceable logic, not a spaghetti mess of joins and CTEs. The config block is what turns a plain SQLX file into an actual model in Dataform. Without it, you're just writing SQL. No outputs, no lineage, no pipeline. This is where you define what the file creates and how it behaves. You'll use it to set things like model type, tags, descriptions, and optional settings like clustering or partitioning. For BigQuery, specific logic, you nest options inside a BigQuery block, like partition by or cluster by. You don't have to memorize every key right now. Just know the config block is required, and it controls everything that makes a model deployable. Views are virtual models. They don't store data physically. They just rerun the SQL every time you query them. Use view when the logic is light or when you want to avoid unnecessary storage. They're perfect for reusable building blocks, filters, or dimensional models you don't need to materialize. A table is a fully materialized model. It creates a physical table in your warehouse. It gets rebuilt on every execution, and it's ideal when you want to persist heavy logic, store intermediate outputs, or prepare data for dashboards. You can add partitioning and clustering inside the BigQuery block for performance. An incremental model only updates new or changed data each time it runs. This is useful when you're dealing with large, slow-moving datasets, like logs, event data, or history tables. You'll control how much data to reprocess using an incremental where clause inside your SQL logic. Operations are for raw SQL, things that don't return a table. You use them to run commands like refreshing materialized views, managing metadata, or even cleaning up staging tables. They're not part of your DAG outputs. They just execute logic when called. Assertions are used to enforce data quality. They run a query and expect it to return no rows. If anything comes back, the assertion fails. It's a great way to catch issues early, like nulls in critical fields or unexpected duplicates. You can add as many assertions as you need and tag them like any other model. This one checks for any orders where user ID is missing, a logic issue we'd want to catch before deploying. And that wraps up the core SQLX types. Don't worry about memorizing every config option. You'll be using these types constantly. They'll stick naturally as you build. And in the hands-on lessons coming up, we'll go through real examples for each one.